Hello everyone, today we're going to discuss our topic which is the first order logic. So first, what is first order logic? The first order logic is another way of knowledge representation in artificial intelligence. It is also called as a predicate logic. The first order logic is also known as the first order predicate logic. It is a powerful language that develops information about the objects in a more easy way and can also express the relationship between those objects. So here the concept is the FOL develops the information about the objects, not only the object, but also the relationship between the objects. It means that the knowledge is represented in a form of objects and the relationship between those objects, and it explains about the facts also.
FOL does not only assume that the statement contains facts, but also assume the following objects. So not only the facts. The facts is one thing and also assume the objects. Objects are the term or subjects like cat, dog, house, John, etc. These are all came under objects. And next is the relationship among those objects, such as sisters of, brothers of, house color, etc. It explains the relation between the two people, like she is the sister of her, he is the brother of his, like that. It just explains the relationship between those objects. And the third thing is the functions. Father, mother, best friends, etc. So these are functions. So the first order logic is doing not only deals with the facts, it also deals with the objects, relationships, and functions.
As a natural language, the first order logic has two main parts. One is syntax and semantics. Now, let's see the syntax of first order logic basic elements. So what are the main basic elements here? We have the constants, variable, predicates, functions, connectives, equality, and quantifiers. With the help of these syntax terms, we are all going to represent the knowledge of the first order logic in artificial intelligence. So the constants, or we call it as the number, alphabets, and the names are all comes under the constants. And the variables means you can change it, you can substitute constants into variables. And these are all the variables. And predicates, the predicates are the brother of the father of greater than, less than, or equal to. So this R comes under the predicate. And the functions which give value a given constant, this is the function. And the connectives, this will use to represent whatever the relations between those objects. It implies, negates, and or double implies. And equality, and these are the quantifiers, universal quantifiers and the extensional quantifiers. So these are all the basic elements that we use in the first order logic.
Now, in order to understand predicate logic, we must understand the following, that is predicates and quantifiers. First, we will understand predicates and then we will understand quantifiers. In predicate logic, a statement is divided into two parts, subject and predicate. So, FOL is in the form of P parenthesis X, where P is predicate and X is subject. So, what is predicate basically? So, predicate is a part of a sentence containing a verb or stating something about the subject. For example, James is tall. James is going to be the subject, and an attribute that is something that's gonna state about the subject is tall. So, tall bracket James. So, isn't it in the same form? P where tall is predicate and James is a subject.
So let's go ahead and see some more examples. So our next example is we are going to use quantifiers. So first, what is a quantifier? So a quantifier allows us to express properties of entire collections of objects rather than having to enumerate the objects by name. In first order logic, there are two standard quantifiers, the universal and the existential. The universal is a type of quantifier which is interpreted as given any or for all, while the existential quantifier is interpreted as there is at least one or for some. For example, all happy people smile. Now since we have the word all, we are going to use universal quantifier. For all X, people X. So what do we mean by people X? So it basically means we are storing people in X. So X means people and happy people X. So happy is what? Happy here is a sort of an attribute. The people are happy, similar to James is tall, and all happy people smile. So this implies that smile. What is smile? Smile is a predicate, and earlier we said that a predicate is a part of sentence containing a verb. So the verb we use is smile. Hence we write smile. We write smile, and who smile? X. And we should remember one thing, that most of the cases, whenever we have universal quantifier, we use implication. And whenever we have existential quantifier, we use conjunction, that is and. So our next example is all gorillas are black. Since we have the word all, so for all X, we store gorilla in X. And it implies that all gorillas are black. Now, our next example is some gorillas are black. In here, we use existential because of the word some. For existential X, gorillas X, we store again gorillas and in X and what? And these X are black. we use conjunction here, conjunction as said earlier. Another example is an offspring of a pig is a pig. Now, the subject here is the pig. So we will write for all x, we will store pig in x, and then we are going to use a predicate that is offspring, because offspring is a sort of a relation, hence that will become a predicate. So an offspring y comma x. So we can also consider predicate as a function, because when we write offspring y comma x, it means that y is an offspring of x. So it implies that pig y. So our next example is, if it is Saturday and warm, then James is in the park. So we are going to say that they as a predicate, and then Saturday. Saturday is what? Saturday is day, and warm. Warm is an attribute for Saturday. So if the day is Saturday and Saturday is warm, then it implies that James is in the park. Basically, we can say that the location of James is in the park. As I said, we can consider a predicate as a function. So our next example is, people try to assassinate rulers they are not loyal to. So our subject here is people and rulers, and the predicate would be trying to assassinate and loyal to. So for all x, we store people in x, and ruler, we store ruler in y, and a predicate which is try to assassinate x comma y, because x try to assassinate y. So if people are assassinating ruler, it means that they are not loyal to. Who are not loyal to? So people are not loyal to ruler, so we will use negation. Who are not loyal to? And that is x comma y, which is x are not loyal to y.